Okay, guys, the last thing we do in 6.1 is to graph polar equations. Oh, there's my kitty. Hello, kitty. Go over here. Okay, so some polar equations are really simple. For instance, I skipped this part. What are examples of polar equations? Well, you can say r equals 5, that's a polar equation, or r equals 3.5 sine theta, or r equals -6 cosecant theta. So they're always in terms like solved for r. And so the first type is really simple. So look at r equals 2. Well, remember, r is how long is the distance between the origin and the point. And so that would be 2. So everywhere it would go to 2. So this is 2 right here. So it would be this one, this point, this point, this point, this point. It would be all these points going around, right? So you just draw the circle. So that's r equals 2, just that circle. So r equals -4.5. Well, okay, that really doesn't make a difference that it's negative, because if we're going backwards, okay, 4 is right here, so 4.5 would be in there, and negative would be just in the middle of this circle. So you would just have to draw a circle in the middle of that circle. Now, you don't need this little line right here. That was just me. So that's r equals -4.1, which would be exactly the same thing as r equals 4.5. Going on to the next one. Now, theta equals pi over 3 would be the line at pi over 3. So it's any r, so it would be continuous that way, and it could also be negative, so we have to continue it this way also. So the r equals are circles, and the theta equals are straight lines. So theta equals -7 pi over 6. So if we're going pi over 6's, there's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So right here is -7 pi over 6. So I've identified -7 pi over 6, and I would draw that line. And erase that stuff where I try to figure out where -7 pi over 6 was. So that's the two easy kinds, r equals and theta equals. Okay? So now let's go to the one that's not so easy. It's where you have to actually do some math. So we have r equals 2 sine theta. We set up a chart, theta. We pick angles, and then we figure out what r would be if we pick that angle. So 2 sine theta, if we put 0 in for theta, it's 2 times sine of 0, and you would get 0, 0. Okay, so you would have a point at 0, 0. So I'm going to do a point right there. I'm going to use red because you can see it better when I do my points. So let me erase this and put a red point right there. Okay. So now going back to here, we have make theta pi over 6. So sine of pi over 6 is 1/2. So 2 times 1/2. I'll write that 2 times 1/2. Sorry, I'm using the wrong color for this. 2 times 1/2, which is equal to 1. So at pi over 6, we're at 1, which looks like it's right here. So pi over 6, 1. Shoot, told you I was going to use red. Okay. So right here, this dot right here. Oops, that's way too big a dot. That's pretty funny. You can tell it's a little hard at home, isn't it? Okay, so then going back to pi over 3, that's 2 times the square root of 3 over 2, which is just the square root of 3. And the square root of 3, if you just do it on your calculator, Some of these you get used to doing. So let's do, what is the square root of 3, people? I keep messing up on my calculator. Okay, square root of 3 is 1.73, so about 1.73. So not quite 2. So at pi over 3, it's not quite to 2. So I'm just going to do it a little bit, before. Okay? Now, 2 pi over 3 would be, sine of 2 pi over 3 is still a square root of 3 over 2, right? So, oh, I put this in the wrong place back here. This was 1.73. So we didn't do pi over 2 yet. Pi over 2, sine of pi over 2 is 1. Yay. So that would just be 2. So I have a point at pi over 2 at 2. And then I come down at 2 pi over 3. It is the same thing, 2's positive 2 and times square root of 3 over 2, which is 1.73. So you can see this is going to be symmetric. So this would be a little bit before 2 there. And then at 5 pi over 6, 5 pi over 6, we have 2. And what is 5 pi over 6? Positive 1/2. So we get 1 again at 5 pi over 6. So we have 1. Okay, and so now we do the other one, other side. 2 times sine of pi would be 0. So it ends up coming back to 0. Okay, now sometimes these go on and sometimes repeat. So we'll just check it out. This would be 7 pi over 6. Okay, wait, what's the sine of 7 pi over 6? Now we're into the negatives, and so that would be a negative 1/2. So we get 2 times negative 1/2 or negative 1. But I'm here, and look what happened. So instead of here, I'm on this line, right? This is 7 pi over 6. And I have to go back negative 1, and look what happens. I'm on this point again. I'm on this point. I'm going to show you in purple. I'm on that point again. So I know that my graph is going to repeat. So I'm just going to do that. It's like a seashell. Okay, so that is the graph of 2 sine x. Let's go on. I'll stop this video and we'll do some more practice.